let's look at the problem of graphing cubic functions. And what we mean by graphing cubic functions is functions which are, and we're going to do it in HK form. So an example would be to graph y is equal to minus 1/2 x plus 4 cubed plus 5. And in general, what we're going to do is we're going to graph functions in the form a parentheses x minus h cubed plus k. And you can graph them when they have in cubic functions in different forms, but there's a different method, and that's going to be graphing polynomials. So these are the problems that we're going to look at today. And the first thing you want to do is you want to memorize y is equal to x cubed. And the basic idea of y is equal to x cubed is there's something, you can think of it as the vertex you want to, or a starting point, that's going to be 0, 0. And then what's going to happen is it's going to look up, when you go in a positive direction, it's going to look an awful lot like x squared. It's just going to be steeper. And then when in the negative direction, it's going to be just a mirror image across this x-axis, so it's going to look like that. So the first thing you want to do is you want to memorize that that's basically what y equals x cubed looks like. And if you want to, you can plug in some numbers. 2 is 8. Why? Because 2 times 2 times 2 is going to be 8. 1 is simply 1. 1, 1, and that kind of gives you a sense. Is it starts off fairly flat and gets steeper and steeper and steeper. It starts off kind of flat and gets steeper and steeper and steeper. And that's how they graph y is equal to x cubed. And then what we're going to do is we're going to HK it, if you want to think of it that way. So if you have y is equal to a, x minus h cubed plus k, the h is going to be a horizontal shift, and the k is going to be a vertical shift. So this is a horizontal shift. So in other words, a shift left and right, and this is going to change signs. And this is going to be what's called a vertical shift. In other words, it's going to shift it up and down, and that doesn't change signs. And now the a does two things. If the value of a is negative, then it's going to flip the function. Oh, no, not absolute value of a, just a. If a is negative, then the function flips. And let me show you what that looks like. If this is x cubed, right? If this is y equals x cubed, then if you put a negative 1 in front of it, this part's going to flip here, and this part's going to flip. So this is going to flip across the x-axis. So that's going to look like that. And this side's going to flip this way, and it's going to look like that. So that's going to be y is equal to minus x cubed. And the value of a, the absolute value of a, is going to determine whether it's narrow or wide in the same way that it's quadratics, but we're going to see that with a graph when we put a table. So let's go ahead and do our example. So let's y is equal to minus 1/2 x plus 4 cubed plus 5. So the first step is you're going to find the starting point. And the starting point here is going to be a -4 and a +5, sort of like a vertex, right? That's going to be this point 0, 0. The second thing is we're just going to ask ourselves, does this flip? And this one, since it's a -1/2, it does. And sometimes I just think about, well, what does that mean it's going to look like? Rather than looking like this, it's going to, x cubed, it's actually going to look like that. And we'll see that when we do the table of values. And the third step is you're going to do a table. And the only thing about a table is that the numbers get really big really fast. So put the starting point in the middle. So that's a -4, 5. This is x and this is y. So what you're going to do is you're going to choose any x you want to, and then you're going to plug in to find y. So here what I'm going to do is I'm going to plug in, let's see here, if I plug in a 0 here I get 4 to the cubed, and 4 times 4 times 4 is actually going to be quite a large number. That's going to be 64. So I might want to choose a smaller number than that. I'm going to choose some number that's close to minus 4. Choose one number that's more positive and more negative. 0 is going to be too big, so let's just choose minus 2. The distance from minus 4 to minus 2 is 2 units, so I'm going to go back 2 units and choose a minus 6. I don't have to do that, but if I do that, I get a certain symmetry that's going to make it look prettier. So now I go y is equal to minus 1/2 minus 2 plus 4 cubed plus 5. Minus 2 plus 4, that's a positive 2, so that's 2 cubed. You have to remember PEMDAS here, right? You have to make sure and do things in order of operation. So I'm going to do parentheses first, then do power. So that's minus 1/2 times 8 plus 5, which is going to be minus 1/2 of 8 is 4, so that's minus 4 plus 5, which is going to be a 1. All I did here is I chose any x I wanted to. I choose minus 2. I'm going to use the PEMDAS rule, so I'm going to do parentheses first, so that's minus 2 plus 4 is 2. 2 to the third is 8, so that's minus 1/2 plus times 8 plus 5. I'm going to multiply next, so it's minus 4 plus 5 is 1. Now I'm going to do the same thing. I'm going to plug in a minus 6, so that's minus 1/2 minus 6 plus 4 cubed plus 5. That's minus 1/2 times a minus 2 cubed plus 5. I'm going to do power next. Minus 2 to the cubed is a minus 8. So it's minus 1/2 times minus 8 plus 5. Minus 1/2 times minus 8, negative times a negative is a positive. That's going to be a positive 4 plus 5 is 9. So you're still going to get a symmetry, but be careful here. These two are not going to be the same. They're just going to be symmetric. Now I'm actually ready to graph it. I have my starting point, and I know the general shape, and I have this table of values. So now I'm just going to draw my graph. You want to be careful and think about scale here, because depending on how you draw your graph, you may or may not have room to plug in all your points. Minus 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5. That point is going to be right there. I'm going to plug in minus 6, 5, 6, and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Be real careful here. That's minus 6 and a positive 9 is going to be there. And then minus 2 and 1. Minus 2 and 1 is easy. That's just going to be right there. You're going to get, it's going to be kind of flat here and get steeper and steeper and steeper. Here you're going to start off kind of flat and then get steeper and steeper and steeper. And then this is minus 4, 5, minus 6, 9, minus 2, 1. That's your graph. That's how you graph y is equal to minus 1/2 x plus 4 cubed plus 5. Here's the key when you graph all of these. You have the starting point. It's going to start off pretty flat and then get steep, and then pretty flat here and then steeper and steeper and steeper. So here's the basic shape. Now, it's not always, it's going to be hard to capture that, but if we notice here, I drew it flat here, and then I got steeper and steeper and steeper, kind of flat near the starting point, and steeper and steeper and steeper. And that's how you graph cube root functions. If we want to do domain and range here, domain is all real numbers, and the range here is going to be all real numbers. So actually domain and range are always very simple with y equals x cubed. It's always all real numbers both ways.